like to hear it later. So there we go. We're starting to record at this point. And I'm hoping that you can see my screen. I've got both of the practice tests open and a graphing calculator, and I've got something to write on as well if we when we need that. Oh, hey, how you doing? Good to see you. So we're just getting started. As just a couple words from me, as you know, both of these tests are this weekend. They open Thursday morning and they'll be open all the way through Sunday evening. So there's a test to finish off both of the two classes. Both of them are just tests over a limited amount of material. They're not going to be comprehensive finals like you have in many classes. For Math 0232, it's just over Chapter 7, which is functions and drawing graphs and things, and Chapter 12, which kind of connects in because there's a graphical aspect there that's talking about some real basic statistics. And then on the 1332 side, it's Test 4, and that just covers Chapter 11. Couldn't think for a minute, which is about counting and probability. Both tests are approximately half as long as the practice tests, which is pretty much the way I usually do that, so that they're not too outlandishly long. One thing I've decided to do, they're both timing out at about at 90-minute tests, but I got to thinking, if this had been a normal final exam period, we would have been scheduled with a full 2 hours for these tests. I wouldn't have made them any different, but I would have given you 2 hours. So I haven't set this out yet, but I'm going to put the time limit on both of these tests to be 2 hours. They should only take you about an hour and a half, but the 2 hours will give you plenty of time to, check your work and be careful and maybe hopefully not feel too rushed. So that's about all the words of wisdom that I have to get started. I want to open it up for you guys and see what kind of questions that you might like to have. Feel free to unmute yourself at any time. And we can answer specific questions, general questions, anything you've got will be just fine. Does anyone want to get started first? Don't be shy.
You don't mind.
Yeah.
The y equals 2x plus 5 graph the linear function using a slope and the y-intercept. Apparently, I just missed that one also. So I was trying to figure out how to get started with that again.
Okay. Let me try this one that happened to have come up first because it's sort of the same idea and see if that would help any. So what we have here is called a linear function. I'm looking over here on the left side. It's in the form y equal mx plus b. I'm going to bring up some scratch paper at the same time here. Try to not have too much going on. So as I look at that, the slope is the number that's right before the x. That's going to be negative 5, 6. And the y-intercept is 6. So that the number in front of the x is the slope. The number at the end is the y-intercept. When you use this tool, the graphing tool, and you do it like this, click to enlarge that. It's going to be a straight line. So you select the line tool. And what you do is you start with the y-intercept first. So the y-intercept is the number on the end. And what you do is you click the point on the y-axis at 6, and that gives you 1 point. The slope then tells you how the line moves from that point to another point. The number on the top, the numerator, is called the rise. That's the old-fashioned word for it, how much the line goes up and down. And the number on the bottom tells you how much it goes left and right. So if I look at that negative 5, 6, what that is telling me is that from that first point, I would count downward 5 points. So I'm moving the cursor down. Whoops, I dropped it in the wrong place. Let's start over. So I start again at the 6. That's 1 point. Click there. Then I drop down 5 places, the number on the top. And the number on the bottom is the run, how much I go over. That's 6. So I count 1, 2, 3, 4, 5, 6 to the right. And click right there. So that from the original point on the y-intercept, I would count down 5 and over 6 and click again. Now I'm going to put the one that you said. Yours was something like y equal 2x plus 3, something like that. Do you remember?
Yes, y equals 2x plus 5.
Plus 5. Okay, okay. So let me draw that line as well. There'll be too much on here, but that's okay. If it was y equal 2x plus 5, you'd start with the y-intercept at 5, where it hits the y-axis. The 2 you would think of as 2 over 1. 2 over 1. So 2 is the rise. Here's my teaching assistant. He's helping me out. Okay, buddy, let's go down. No, don't walk on the keyboard. Okay, there we go. The rise is 2, so you would count up 2, and thinking of it as 2 over 1, you'd go to the right 1. So starting at the 5 on the y-intercept, go up 2, right 1, and click again, and that's what that would look like. And then when you have whatever you're ready to save, you click save, and it'll tell you if you're right or not. I've got too many lines on here, so it won't like that, but that's how you do it. Does that help?
Yes. My points were just totally different. I was on the 5, but I didn't go up. I went down.
Yeah. So if the slope is positive, you're going to go up.
Yeah.
If the slope is negative, you're going to go down. Good. Good. Does that help? Good. Okay, great. All right. Who wants to go next? Or you can give another one, either way. Looks like there's just 3 of us, so everyone can ask as many questions as you like. Anybody else? Don't be shy.
How about find the slope of the line passing through the pair of points, or state the slope is defined or is undefined. Then indicate whether the line through the points rises, falls, or is horizontal. I got 1 and 0 in parentheses.
Okay.
And 0 and 6. And somehow I got the line falls from left to right. But somehow I ended up with -6.
Okay, let's take a look at that. So I'm going to call up a special thing here. All right, so I'm going to first of all write the formula for slope. Slope is given by a fraction. It's the difference of the 2 y values. So y2 minus y1 over the difference of the 2 x values, x2 minus x1. Probably the most dangerous thing is just getting the numbers in the wrong places. The y2 will refer to the y value of whatever you call the second point. The y1 is the y value of whatever you call the first point. So when I plug in, build this fraction, the y2 would be the second value of y you gave me. That would be that 6. And the y1 would be the first value of y. So 6 minus 0, sorry. y2 minus y1. And in the denominator, you'd have x2, the x from the second point, minus the x from the first point. So 6 minus 0 over 0 minus 1. So far, so good. Now, 6 minus 0 in the numerator is going to give us a 6. 0 minus 1 in the denominator is going to give me a negative 1. So it's 6 divided by negative 1. And a 6 divided by 1 would just be 6. But anytime you have a positive number divided by a negative number, the answer will be negative. So the slope should turn out to be negative 6. And a negative slope should tell you, and if you draw the picture, it should look this way. Actually, we can go back over here. We had, I'll just borrow this. 1, 0 is right here, and 0, 6 is right here. So if you look at it from left to right, the graph is falling, going down as you look at it from left to right. How's that look?
That's weird with your answer because I have -6 as the slope. And oh, hold on, excuse me. Never mind. I'm sorry. I see. They gave me that answer. So okay, I must have screwed that up somehow. All right.
Oh, okay. Okay. Yeah. The answer that pops up first in my math lab is the right answer, and you have to click the little red triangle to see what you wrote. Perfect. Okay. All right. Who would like to go next?
Hi, Professor.
Hi, how are you doing?
I'm good. How are you?
Good.
I have a question. X equals 4. I think you would substitute the Y value for 0, but I'm not sure.
Okay. And they're asking you to graph it?
Yes.
X equal 4.
Mm-hmm.
Okay. So there's something you can memorize, and that's a good thing. But there's also just sort of a general idea that you could go with that might help you, because where people most get confused is X equal 4 versus Y equal 4. Which one is which? So I'm going to try a little trick here. I'm going to insert a table. So imagine that you are creating one of those little T tables where you plug in the values for X and Y. This one's a little bit fat. Let me skinny him up a little bit. So you're going to make a set of values for X and Y. So there's going to be something you can just memorize, but this will help in case you get confused, which is easy to do. So the equation says X equal 4. So when you choose ordered pairs, no matter what you do, X has to be 4. You got to put a 4 right there. Now the Y is not mentioned. If in an equation they don't mention the value of Y, that means you can put in anything you want. I can put in a 0. X always has to be 4. I always have to put a 4 for X, and Y can be anything. So I'm just picking random numbers. As long as the X is always 4, the Y, well, let's put a negative in there too. The Y can be anything, but the X has to be 4. So if we look back over here and see what that's going to look like, let's just cancel that out and start a new one. Don't worry about what the equation says there. I just need this. So if you look at the points, 4, 0 would be right here. 4, 5 would be up here. 4, -3 would have been down here. I only need 2 points to draw a line, but just to keep it going, 4, -3 would be here. 4, -8 would be here. 4, +8 would be here. So if you go with that idea, then you realize, oh, this is a vertical line. And that is going to represent the fact that no matter what, equations in X only are always vertical lines. But it is really easy to get on tests and say, oh my goodness, which one's the vertical one? Which one's the horizontal one? This is the general principle you go with. So if I had changed this and said that I wanted y equal 3, I didn't want that to be capitalized. Oh well, y equal 3. If I do the same thing, now this one's going to be horizontal. But if I make a t-table for this one, it'll be kind of the reverse situation. Because the y is mentioned, y has to be 3, but the x can be anything you want. So y has to be 3. You got to put a 3 where the y is. But for x, you can put any number you feel like. You could put a 0. You could put a -2. You could put a +4. And then if we look at what that looks like, the point 0.03 would be right here. -2,3 would be over here. 4,3 would be over here. And so what you see is that an equation in y only, those are going to be horizontal lines. So whether you actually memorize, and if you do this a whole lot, you do kind of accidentally memorize that x equals something is a vertical line, y equals something is a horizontal line. But you can always make a little table like this and just make some ordered pairs and plot them, and then you'll see right away, oh yeah, that one's vertical and that one's horizontal. How's that look?
Yes, I understand now. Thank you.
You're welcome. You're welcome. Good. All right. What next? I'm wondering, you can tell me the chapter 7 stuff, which is kind of like true college algebra. It's the only real college algebra stuff we do in this class. I wonder if that's the part that was kind of the trickiest. What do you
Most
think?
definitely.
Okay. Yeah. Yeah, that's, if you've been in college algebra, you would have spent the whole semester doing that, and you would have graphed parabolas and circles and all kinds of crazy stuff. So we're doing completely different stuff, but we needed to have just the basics of how a function works and how to draw a graph, basically so we could look at those bar graphs in chapter 12. That was kind of the purpose for that.
I was having some issues with the parabola. I forgot how to pronounce it, but it's the curved one. I couldn't tell when to use the curved one and when to use the straight line.
Oh, okay. Yes, yes. So you may have had an equation to deal with something like this. Maybe, say, that you were trying to graph. And let me just do a quickie here. Oh, it's confused. Hold on a second. Oh, that's all right. Let me just leave right there. That's good enough. So you're looking at y equal x squared minus 5. For our purposes, we do everything by just drawing one of these tables. And I don't know why y equal x squared minus 5 doesn't want to show up here. I'm going to do it kind of an ugly way. That's old-fashioned notation for x squared minus 5. And I'm going to insert another table. So the trick, or what's going to turn out to be the case, is if there's an exponent, if there's a square on the variable, that's going to create the parabola. The other equations we've looked at do not have squares on the x anywhere. Those are going to be lines. So, but here's how this can work. You have to make a table essentially. And on some of the questions, it tells you what to plug in, but for a lot of them, you don't. It doesn't. What I like to do is I just like to pick some negative numbers and some positive numbers. And I don't like them to be big because I don't want to work too hard. So, you know, -2, -1, 0, 1, 2, a few things like that, and plug them into the equation and see what I get. So if I take -2 squared minus 5, the -2 squared is going to be -2 times itself. -2 times -2 is going to give me a 4, positive 4. Negative times negative is positive, minus 5. And that's going to tell me that the y value right there is -1. -1, when you square -1, it'll be a positive 1. Subtract 5. 1 minus 5 is going to give you -4. Plugging in a 0, 0 squared is 0, minus 5 is -5. And then you begin to notice something interesting. The y values start repeating themselves. If you plug in a 1 for x, 1 squared is 1, minus 5 is -4. And 2 squared minus 5 is 4 minus 1, that's -1. So I'm going to go over to my graph paper over here and just kind of, without really drawing anything, just kind of point out where those points are, and you'll begin to see why it's going to be a different shape. So the points I'm going to have are -2, -1, which is right about here, and -1, -4, so that goes down here. 0, -5 goes down here. 1, -4 comes back up, and then 2, -1 is going up even more. So when you just think about where the points are going to land, you realize they're not going to be a straight line anymore. They're going to be this U shape, this curve, and that's going to be a parabola. So how do you use the tool for that? That's this one. And the way this works is the first thing you do is you figure out where the vertex of the parabola is going to be. That's going to be either the high point or the low point. So if you think about where those points were, -2, -1, 0, -4, -1, -4, 0, -5, 1, -4. Notice that the whole thing sort of turns at this point. This is a low point right here. We call that the vertex. Click that point first, and then move your cursor to any other point. Notice how it forms a nice symmetric shape. So I'm just going to move over to the point 2, -1, and click right there. And then this should match up with all the points in my table. Let's just see. -2, -1, that's right about there. -1, -4, that's right about there. 0, -5, obviously. 1, -4, and 2, -1. So that gives me the shape of that parabola. What's causing the shape is going to be the x squared in the equation. So if you want kind of a quick, easy way to say, ooh, I think a parabola is coming. If there's no exponents on the variable, like if the equation is just say, well, like one we just did a little while ago, y equals 2x plus 5. There's no exponent on any variable. That means it's going to be a straight line. If the x is squared, that means it's going to be a parabola. And then in college algebra, you find out what happens if you have an x to the 3rd, if you have an x to the 17th, if you have a square root over the whole thing, like the square root of x. All that gets much more involved, and we don't need to do that. Does that help?
Yes. So when you're choosing your points, you look for the one that has that. You start with the one that has the point first, and then you kind of map them out from there.
Yes. Yeah.
Okay.
So you try to look for that pattern where the graph is either having a low point.
Okay.
This in front of the camera, where it has a low point or a high point. If you can find that point called the vertex, that lower high point, and start with that one, and then just pick any other point.
Okay.
That one that tool takes a while to get used to. It's a little strange.
Mm.
Does that help?
Yes, it does. Thank you.
You're very, very welcome. All right. Who wants to go next?
Well, 7x equals 2y plus 14. Yeah, I thought I got the, I ended up with x equals 2, 0, and I tried to plot it, but I guess that was wrong too.
Okay. So I get the equation right? X equal 2y plus 14. Right there.
7x.
Oh, 7x. Oh, I've got it totally wrong. I've got it just completely wrong. Tell me one more time.
7x.
Okay.
Equals 2y.
Oh, I'm totally screwed up. Okay, let me try again. 7x equal 2y
Plus 14.
plus 14. Perfect. Okay. All right, and I bet the equation or the instructions say something like find the x and y intercepts or something like that. Does it say that? Maybe it does, maybe it doesn't, but it's asking for the graph, right? Yeah, I think you're muted. Let me see if I can unmute you here.
Oh, yes. Yes, you can intersect the graph linear function.
Okay, great, great, great. Okay, so if the equation happens to be written in what we call slope-intercept form, like the very first one we did, just plotting the y-intercept and the slope is good. If it's not written in that form, the easiest way is to find the x and y intercepts. And the way you do that, you kind of make another table, but you only need a couple things in this table. Scroll down a little bit. So it's still an XY table, no big deal there. But what's different is to find the intercepts, you do some really easy calculations. You first of all just plug in 0 for x, and then later on you plug in 0 for y. Now, if you plug in 0 for x, your equation would become 7 times 0 equal 2y plus 14. And that means that the left side of that equation is just going to become a 0. 0 equal 2y plus 14. Now, we're going to solve for y, which you might be able to actually even just do in your head. But what I would see to do is I would subtract 14 from both sides. And that would give me negative 14 equals 2y. And then I would divide both sides by 2. And I think we can just do that in our heads. If we divide negative 14 by 2, we'll get negative 7. And that is going to correspond to the y-intercept. When the x is 0, you get the y-intercept. And when you let y be 0, you get the x-intercept. So if I go back to the equation and plug in a 0 for the y, I would have 7x equals 2 times 0 plus 14. So see, that's the 0 for y. And that gives me 7x equal 14. And divide both sides by 7, and your x value would be 2. So just plug in 0 for x, just plug in 0 for y, and then when we come back over to our graph over here, we're just going to keep picking on this because it works just fine. This will be a straight line because there were no exponents. and the points would be 0, -7. You click that one, and 2, 0, you click that one. And it should look like that. So that is a very fast way to graph a line if it's not automatically in slope-intercept form. Slope-intercept form, again, would look sort of like that very first example that we did. Y equal 2x plus 5. If the equation is solved for y equal mx plus b, then all you need to do is plot the y-intercept and measure the slope. But if it's not set up that way, like here, then plugging in 0 for x and 0 for y gives you a quick way to get those get 2 points. What do you think? Does that look good? Okay, great. Okay, who wants to go next? I can see graphs, or that's what everyone's interested in. When I teach college algebra, that's the thing that students struggle with the most is the graphs. It's hard to say, how does an equation become a picture? Yes, I heard someone click in. Another question? All right. Anyone who has one, I'm glad to take.
Man, I guess I must be slow today.
Hey, you have to be the man of the hour. Good for you. I mean, I bet that every question you're asking is something that other people have at least thought about. So, so go for it. There's just like 4 or 5 of us, so make the most of the opportunity.
In the practical final exam, the review test, the bar graph below shows that as costs changed over the decades, a group of people devoted less of their budgets to groceries. And that was the percent of total spending is from 0 to 30, with the difference in between is 6 increments. So 0, 6, 12, 18, 24, 30.
Mm-hmm.
But it has the years 1950, 1970, 1990, 2010. And I think it's number 15 on here.
Yeah, the order might be all different.
Okay.
See what let me just page through. Let me start at the beginning and page through.
Okay.
That's kind of the one unfortunate thing. This scrambles the questions. But I know which one you're talking about.
That one.
This is it. This is it right here. Let me see if I can make it a little bigger. Oh, it doesn't really help. Okay, cool. So yes, everyone will have one similar to this. It'll probably be generating different numbers for everybody. The bar graph below shows that as costs change over the decades, a group of people devoted less of their budget to groceries. In 1950, the group spent 25% of their budget on food. This has decreased an average rate of approximately 0.28% per year since then. Find a linear function in slope-intercept form that models the percentage of total spending by the group X years after 1950. Okay, so basically what they are doing here is they're describing points on a line. 1950 corresponds to year 0. And the year is going to be your X value. The Y value is going to be the percentage of the budget that is used in that year. So in 1950, the average person had to spend 25% of their budget on food. That would correspond to the ordered pair 0, 25. The first number is the year, but measured this way, and the second number is the percent. So if I were going to go all the way down to 2010 to figure out what that ordered pair looks like, just to kind of understand this, the X value is the year, but it's the number of years since 1950. how many years after 1950 is 2010? How many years later is that? So if you think about it, from 1950 to 2000 would be 50 years, and 2010 would be 60 years. So you'd have an X value of 60, representing 60 years after 1950. And then the Y value is the percentage of the budget spent on food. So really what we're looking at is more or less, if you can imagine this, a straight line, sort of, it's approximate, that goes from here to here, and they're wanting us to write the equation of that line. Now, the big deal is once you understand what the ordered pairs are, this one right here, the 0, 25, notice that the X is 0. If I were to graph that, if the X is 0, that would give me a point on the Y axis. So this is actually the Y intercept of the graph. And the rate of change, which they talk about in here, basically is the same thing as the slope. Slope tells you how much the graph changes as the X increases. What does the Y do? That's basically a description of change. So when they mention this 0.28% here, that's really referring to the rate of change per year. And that's really their way of coding for you that that number there is the slope. So the y-intercept is 0.25 and the slope is 0.28. And I think they maybe mentioned that that's the slope in there. Yeah. So how do we write the equation? Well, we know that equations of lines can be written in slope-intercept form like this, where m is the slope and b is the y-intercept. So I'm going to go back up into their answer key right over here. I can use that 0.28 for m, and then the x, and then the b is actually just the y-coordinate of the y-intercept. That's going to be 25. That equation, which is an equation of a line, is a rough model for what the line would look like if you were to draw a line from here down to there. And you can see it wouldn't be perfect. It's not exactly a line, but it's kind of like a line. That should do it. Oh, it gave me the wrong answer. What did I do wrong? Okay. Well, that's not what I wanted to happen. 0.25, 0.28. Oh, maybe they wanted everything not as percentages, but converted to decimals. So let's look at that. 0.28%. If I made that into a decimal, somewhere else we study that, it'd be point. You have to slide the decimal 2 places to the left. So that would make it 0.0028, and then 25% would be 0.25. So 0.25 is the y-intercept as converted into a decimal, and the 2.8% converted to a decimal would look like that. Let's see if that makes them happier. Okay, that makes me unhappy.
Mine came up with a negative 0.25 minus the.
Oh, yeah. Okay, I'm sorry. Yep. I don't think we need to convert that to decimal. I made a rookie mistake there. Let me go back and talk through that. This is the rate of change, but notice it says that it's decreasing. And that makes sense. As I look at this line, it looks like it's falling from left to right. A line that's falling from left to right is a negative slope. So I need to use that 0.28, but I need to make it a negative 0.28 to indicate that it's going down. Negative slope. So when you see the word decreasing, it's going to be a negative slope, increasing a positive slope. Let's try that. and try it without percents and see if it's happy with that. So, or just leaving the percents as percents. Let's see if that looks okay. I got it right. Okay, so that was the problem. My apologies. The decreasing implies that the rate of change is negative. So we're going to use a negative slope. So that was kind of clumsy. Sorry about that. Does that make sense though? Okay. One of the primary objectives of this class is called mathematical modeling, to write an equation that that mimics real world data. And that's really what this question is getting at, to take what you learned about straight lines and kind of apply it in a particular setting where words like slope and y-intercept are hidden behind an application problem. So actually it's pretty easy. Just remember the rate of change is the slope, increase positive, decrease negative, and whatever y value is associated with the x value of 0, that's your y-intercept.
So you found your plots by looking at the grid where you took the percentages and you turned that into, I think, your y. Mm-hmm. And then you took your the vertical, and that was your x.
So the trick here is it's really built on this statement. Where did they say it? X years after 1950. This little phrase right here is the important one, because what that's saying is they're counting 1950 like year 0, because they don't want to deal with big numbers like 1950 and 2010 and all that. So as soon as you see a phrase like that, X years after 1950, what that makes you realize, coming back over here, is that one of the points they're giving you has x equals 0. In this case, year 1950 was 0, so whatever y value goes with 1950 creates the ordered pair 0, 25. And because the x value is 0, that turns out to be the y-intercept, which is the value of m in the y equal mx plus b formula. So that's how you know that. They could have, for example, said X years after 1970, measuring everything from 1970. And what that would tell you then is that you'd use the ordered pair 0, 18, because your year 0 is a different year 0. Does that make sense?
Yes.
Okay, and then you'd use 0, 18 instead of 0, 25. The slope is always the rate of change. That's what you want to hang on to, that rate of change equals slope. So whenever they talk about, and you just look for keywords, here's what I'd be looking at. This has decreased at an average rate, that word right there. When I see that word rate, I realize, oh, they're trying to tell me what the slope is. And then the next number that follows that should be the slope, with the extra thing to watch out for, that when they're describing rate of change, they're probably not going to put a positive or a negative. You have to look for a keyword for that too. If things had been increasing, it would be a positive slope. But the fact that this was decreasing, oh, I made a mistake here. Y-intercept is B. The fact that it's decreasing, your slope would be a negative, whatever they're saying. And then you take those two things and plug them into the formula y equal mx plus b. And that's how I got the negative 0.28x. The negative 0.28, that's the rate of change, the slope, and the 25 is that y-intercept. Does that make sense?
Yes. Which chapter would this be found in? I think it's 11.2.
Chapter 7.
Oh, yeah. I think it's like 7.2, I think. I'm not sure.
I think so. Yeah, I think so.
Okay.
I think that's right. Actually, oh, you know what? I've got the syllabus right here. Give me a second. I can look it up. I was trying to figure out how do I not get 42 more windows open. Yes, it is exactly right. This is 7.2.
Okay.
7.1 is the general graphing, and 7.2 focuses in on the lines and has all these word problems in it.
Okay.
If the word problem is showing you any kind of data and asking you for an equation, that's going to be 7.2. There are other questions with pictures, but if they don't ask you for an equation, let's see how fast I can find one. Oh, there's a picture, very different. But they're not asking me for an equation here. That's going to be section 12.1 on look at representing data graphically. So you can kind of see it's a very close connection, but if they're not asking for an equation, they're just drawing you some sort of graph, of, whether it's a circle graph or whether it's a bar graph, then that's going to be in chapter 12. There, oops, I went away too fast. This would be chapter 12 because there's not asking for an equation. They're just showing you the graph and asking you stuff about it.
If we're moving on, let's go with that one then.
Let's do that one. Okay, let's do that one. We're in the neighborhood. Let's make good use of the time. So let's see what this is asking for. This is asking us to calculate a couple of things. We're looking at measures of central tendency. The measures of central tendency are mean, median, mode, and mid-range. The cool thing about it is any word that starts with an M in it probably has to do with central tendency. So mean is just an average. Now, when I look at this, I have to think, well, how am I going to figure the average of these? Because it's not just a list of numbers. The numbers are occurring more than one time. So this is probably a little too tedious, but to get a sense of what's going on here, what this bar graph is telling me is that the only data that ever shows up is either a 10, 11, 12, 13, or 14, but there's more than one of each of those. Notice that above the 10, the bar graph gets up to what looks like probably 3. What that means is if I were to write out the whole data set, I would have 3 10s. How many 11s do you see? Can you see that?
Sorry, we're looking at your chart. Okay, 11s, 4 11s.
4 11s. So you might remember some of the other homework just gives you lists like this, where you just get the list. That's what I'm going to look at here. 12, the fact that this bar graph goes up between 6 and 8, there must be 7 of those. So I put in 7 of those. 1, 2, 3, 4, 5, 6, 7. And it looks like 4 13s and 3 13s. 14, sorry. So this picture represents this data. And that gets you kind of more in the realm of what you're used to seeing. So we can first of all figure out how many numbers we have here. Because if we want to figure out the mean, that's the first one they want. What you do there is you basically add up all the numbers. And then divide by the number of numbers. So I need to know how many numbers there are. I can either count and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I think there's 21. Okay. That's what I'm going to divide by. And I would add up all these numbers and divide by 21. Now, there's a fast way to do that on your calculator. Rather than going 10 plus 10 plus 10 plus 10 plus 10, you can build on the way that chart is presenting things and take advantage of that. The fact that the 10 bar goes up to 3 means you've really got 3 10s. So rather than going 10 plus 10 plus 10, you could say 3 times 10. And then you have 4 11s, so 4 times 11. And 7 times 12. And 4 times 13. And 3 times 14. So that's a little bit easier. Whoops, sorry. I didn't want that to happen. Oh, I got to start over. Okay. 3 times 10 plus 4 times 11 plus 7 times 12. Actually, let me do it here on the keyboard. Plus 4 times 13 plus 3 times 14. That would be equivalent to adding up all the numbers in this big old long list here. Let me just make sure I did it right. 3 14s, 4 13s, 7 12s, 4 11s, and 3. Yeah, that should do it. So I hit enter. And that's the number that you add up all the numbers. You get 252. And you take that number and you divide by the number of numbers. And that was 21. 21 is also the sum of these frequencies. If you think about it, you'd have 3 plus 4 is 7, plus another 7 is 14, plus 4 is 18, plus 3 is 21. 252 divided by 21. That should be your mean. Oh, came out to be a whole number. That's pretty amazing. So the mean is 12. Okay, so mean, just add up the numbers and divide by the number of numbers. So far, so good? Now, median is the number that's right in the middle. That's the next one asked for, right? Yeah, median. Look at the whole list of numbers and look for the number exactly in the middle. Now, if you went to the trouble of writing this all out, you can actually figure out what number in here is right in the middle somewhere. There is a trick for finding out where it is. The position of the median is always given by n plus 1 divided by 2. Oh, let me do it differently here. What am I doing? Okay. This way. Oh, where did that come from? Sorry. There we go. Sorry about the technical difficulties there. Oh, there it is. Okay, great. So in this case, what we would be looking at, we counted up the number of numbers and there were 21 numbers. So you take 21 and you add 1 and then you divide by 2. 21 plus 1 is 22, divided by 2 is 11. So that means that the median is whatever number is in the 11th position and you just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you should get to the same place whether you count 11 from the bottom or 11 from the top. So let's just check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 is right in the middle. So that's going to be your median. Now, if you don't feel like writing all those numbers out, which could be tedious, you could also do it this way. Just looking at the chart, you can still figure out where the 11th position is, even if you don't have the list, because here's how you could do it. You know there are 3 10s, so it's not going to be a 10, it's too soon in the list. There's 4 11s, so that would get you to position number 3 plus 4 or 7. And that's too soon too. You're wanting the number in position number 11, and by the time you count on all your 11s, you've only got 7 positions. Now, there's 7 12s. So you're going to have 12s all the way up until you get to position 14, which is 3 plus 4 plus 7. So you're going to have 12s from position 7 through position 14, and position 11 is going to be in there somewhere. So even without writing it out, you can figure out that 12 would be that one that's somewhere in where position 11 ought to be. And if all that is too vague and esoteric, just make the list and then you can count it. So the median should be 12. The mean and the median are the same. Let me just pause right there and make sure those are okay, because those are the mean is the one that's the most trouble to calculate. The median is the one that's weirdest to figure out. Does that make sense? We okay so far? Okay, I see a nodding of head. Good. Mode is the number that occurs most often. And mode is super easy to figure from a graph. It's the number that occurs most often. You could look at your list and see which number occurs most often. That's pretty obviously a 12. But even in your graph, it's pretty obvious. It represents the highest bar. The highest bar represents the most number of entries. So the mode is going to be, once again, 12. Mean, median, mode. Mode is the number that occurs most often. Still okay? And mid-range, that's for that, right? Yeah, mid-range. Mid-range is kind of almost useless. It doesn't really tell you much of anything. But the way you figure it is you take the lowest value in your list plus your highest value, and then you divide by 2. So you're averaging the highest and lowest values. In this case, what you would do is the lowest number anywhere on your list is a 10. The highest number anywhere on your list is a 14. You add those together, and then you divide by 2, and that's the mid-range. And oddly, they all turn out to be the same. 12, 12, 12, 12, 12. But they're all figured differently. Mid-range is probably the least statistically significant of all these measures. We talk about it just because it's there, but it's just take the lowest number you see plus the highest number you see and divide by 2, and that's all you do. Since I screwed up that other one, let's just make sure. Oh, yay, I got it right. Okay, I get 100 on that one. All right. So that gets us a little bit into chapter 12, measures of central tendency and looking at graphs also. That's kind of all a good thing. Tell you what, I'm going to give you a bonus on this one. It doesn't talk about this in this question, but there's 2 words that almost sound like they're talking about the same thing. There's mid-range, and then there's just range. Range is technically called a measure of disbursement. And I obviously misspelled that word, but how much it's spread, it means how much is the data spread out. So forgive my spelling. I don't know what I misspelled wrong. Disbursement tells you how much the data is spread out, and all the range is, it's just the difference of the largest value and the smallest value. You take whatever number is the largest number on your list, and you subtract whichever number is the smallest on your list. And that number tells you that the data is spread apart 4 units from the smallest number to the largest number. That's not mentioned in this question, but it's a good thing to throw in. This would be section 12.3. And all of these other fellows that we talked about with central tendency are 12.2. So when you see range, it's like super easy, just the difference of the two.
Thank you for that one. I totally forgot about that one. I was doing the practice test earlier and I was like, range? I don't think we've gone over that one.
Section 12.3 was super short. That's all we talked about. Just what is the range? And that's how you do it. Just take the biggest number minus the smallest number. It's really easy. Get free points. Okay. Anybody else?
If not, I have another one.
Sure.
One of these is evaluate the function at the given value of the variable.
Great.
There were 2 variables given, and I got the first one right, and I just tried to recalculate it again and again, and it says 100, but my calculator has negative 116. The equation was f parentheses x equals 3x to the second.
Okay.
Plus 2x plus 4.
Excellent.
And the first variable was 4.
Okay.
And the second variable was negative 6.
And that's the one that gave you trouble?
Yes.
Okay. All right, let's look at that one. And in particular, I'm going to do it on the calculator. Get rid of that. Okay. So here's the question on the left, and here's the calculator on the right. Okay, let me close some windows here. There, now we can see everything. All right, so when we do f of negative 6, I bet there's going to be a problem with parentheses. I bet that's the deal. So if I want to do the whole calculation all at once, I would need to say this, 3 times, and because all of x is squared, including the negative, you would want to open a parentheses so that negative 6 is all together in parentheses. Then square it plus 2 times, and again, to be safe, let's just put the x in parentheses so that we're using all of that x, and then finally plus 4. So I am going to bet, not to pick on you or anything, that there's some parentheses missing when you did it on your calculator. This should end up like that. Here's what would happen if you don't have the parentheses. I'll show you what it's doing and why it's doing it. If you had just said 3 times negative 6 squared plus 2 times negative 6 plus 4, which is literally how it looks without parentheses, your calculator is going with order of operations, which means it thinks you want to do this exponent first before the minus sign. And it's going to say, oh, the only thing he wants me to square is the 6, and then put a negative in front of it. And so if you do that, you'll get a different answer. So the key is there, whatever x is, if it's a negative, just put it in parentheses, and it'll all turn out fine. Is that what happened, do you think?
Yes, sir.
Okay, good. Good.
Thank you.
Easy fix. Easy fix. Okay, anything else? Well, we've gone about an hour, which is sort of what I was planning on. If anyone has one more question they're dying to ask, I certainly don't mind at all. Anyone have something they're dying to ask? Don't feel shy. Tell you what, we are going.
Question on the slopes with the equations from the x1 and the y1 and the x2 and the y2.
Mm-hmm.
Is that formula always structured that way?
Yes. Yes, it always is.
Okay.
Yeah. So it may be back up here somewhere. I can't remember. I think we did.
Yes, we did.
Well, now I don't see it, but yeah.
Sometimes what throws me is where I try to structure the x1, y1 with the x2 and y2 formulas. That's usually what throws me off when you're trying to set up those combinations.
Okay. I know it's here somewhere, but I can't find it, so I'm just going to do it again. The formula is y2 minus y1 over x. Sorry, this is kind of clumsy. 2 minus x1. So let's say that I give you a pair of points. I'm just going to make up a couple if that's all right. I've got this point and maybe this point. I'll tell you what, I'll make this one negative just for variety and this one positive. Okay, so the easiest way to relate to this equation, I think, is rather than get too hung up in what these subscripts look like and how confusing they look, just think of it as y2 means the y from the second point. So if I think of it that way, the y from the second point is 7. y1 is the y from the first point. So that's -2. Now, I do have to make sure I'm watching the signs here. There's the minus sign from the equation and the minus sign from the point. And notice I'm putting my negative in parentheses there again. So the y from the second point minus the y from the first point, that goes on top. In the denominator, I take the x from the second point. This, when you see x2, don't let that be all like scientific and weird. Just say x from the second point minus the x from the first point. So -5 minus 3. That's going to be my equation for slope. So far, so good. Then if we simplify that, my hand keeps wiggling. If we simplify that, 7 minus negative 2. So minus a negative is the same as adding. So that's 7 plus 2. That's a 9 on the top. 7 minus negative 2, same as 7 plus 2. And minus 5 minus 3 would be a negative 8. So my slope, putting the negative sign off to the side, would be negative 9 eighths. Let's put that back over here. Does that make sense? So don't get hung up on the y2s and y1s, just y from the second point minus y from the first point, x from the second point minus x from the first point. And the only way you can really go wrong is if you take your points out of order. Just the y2s are always the second point. Y2 and x2 are from the second point. X1 and y1 are from the first point.
Makes a lot of sense now that you said it.
Okay,
I
good.
figured it out now. So
Okay, great, great. Very, very good.
So we will plot that as the 9 first, down 9. Plot on the.
Oh, yeah. So this by itself would not be an equation because it's only the m value, but you might have an equation that has that in it. You might have, for example, y equal negative 9 8 x plus 6, let's say. That would be this, the negative 9 eighths is the slope by itself. An equation of a line might look something like that. Now, if I can get back to one of my nice tables, hold on a second. Okay, I'm just using this to get this graph. Okay, now I've got too many things open, I can't see. Okay, here we are. All right, so here's the equation I want to look at. Y equal negative 9 eighths plus 6. I'm going to try to graph it. The second number, the B, the number by itself is the y-intercept. So you click the line tool, and you start with the y-intercept at 6, and you click that point right there. Negative 9 eighths is rise over run, and you always think of the negative as being in the numerator. That's the easiest way. So negative 9 means you go down 9. So from that point, you count down 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 down, and then 8 to the right. Oh, shoot. I accidentally clicked. I didn't mean to do that. Okay, so 6, go 9 down, which puts you to right here. And then 1, 2, 3, 4, 5, 6. Oh, stop it. 7, 8 to the right. And hopefully you're more coordinated than I am. So not from your y-intercept, go down 9 and then go to the right 8. Look good?
thank you.
Okay. Great. Well, it's been good to have you guys with me. I hope this has been helpful and cleared up some questions that you have. I'm offering another one of these tomorrow at 2:30. You're welcome to come back. If you want to look at some more questions then, just keep looking at your practice tests and come back tomorrow if you want. And of course, if you have any questions just in between time, feel free to email me or send me a text through Remind, and I'll be glad to get back with you and help you out with whatever you have.
Is tomorrow centered around 1332?
Actually, I'm just sort of making them whatever questions anyone wants to ask. This one's been very much focused on 0232, so maybe tomorrow will be more 1332.
Okay.
So if you want to play with that practice test and think of some questions you might want to ask there, we'll probably spend more time on that tomorrow.
Yes, sir.
Okay. Thank you, guys.
Thank you.
Okay, I've been recording this whole thing, so once the recording is done, I'll also email you the link in case you want to watch it over again.
Yes, sir.
Okay, y'all take care.
How long would it be before the link get up?
It sometimes takes overnight to process.
Okay.
I don't know why it does that. It sometimes is quicker than that, but it doesn't. It has to go through some magic that I don't understand. And then once it's gone through the magic, then it creates a link for me. So it may be as late as tomorrow morning.
Okay.
Okay. Well, y'all have a good evening and maybe see you tomorrow. And if I don't see you tomorrow, good luck on your test.
Hey, thank you, sir.
Okay. Y'all take care. You bet. Take care.
Bye-bye.